Hi, I'll go over Lab 3 of ECE 285, which is regarding mesh and nodal analysis. So for experiment 1, you have a nodal analysis circuit with R1, R2, R3, R4 being 10K, 1K, 2K, and 1K respectively. In my demonstration, I changed some of these resistance. So let me switch over to my camera. Okay, wonderful. So these are my components right here. We saw the 10K, the 1K, and the 2.2K. So this is the right branch. This is my left branch if you look at the schematic. But I replaced that 1K for R2 as 3K. So now I'm going to connect my voltage supply. So I need output 10 volts. So I'm going to connect the +5, the top, and then -5 at my ground. And then I want to measure the current flowing through R2. So if I want to do that, I have to actually remove this 3K and then push it up so that way I can place my multimeter in series with the circuit. So let me get this. Okay, cool. So now I switch to current mode as indicated right here. There you go. Now you can see it better. And then I will just place my positive cable up there, right on the same row as where that R2 connects, and connect that to my ground. So now I have my multimeter set to measure current, so I'm good with that. Now I just want to measure the voltage, right? Or at node 2, which will be the voltage drop of R3. So what I'm going to do is going to get my positive channel 1 cable and connect that at the orange right there, and then connect my ground cable, or sorry, my channel 1's negative at my ground. So I'll just find that right there. Okay, cool. So that is my circuit. So it's pretty messy, but here's what it looks like. So positive voltage right there, negative voltage on that row, negative of the channel 1 connected on that same row. Also, my negative from my multimeter is connected to that same ground as well. The positive is connected to the same row as that 3K. And so I will be measuring the current going to that 3K. So when I switch over to Scopy and turn on my voltages, you can measure the current and observe the voltage drop at the exact same time. So give me a moment to set up Scopy. Okay, so go to power supplies, 5 volts positive, -5 volts, enable that. And then if I switch over to my voltmeter, you will measure a voltage drop. This voltage drop will not be the same for you guys because there's a slight difference in my resistance for R2. But when I switch over to my current, you can see it's about 0.4. Oh, spiked a bit. There we go. So it's around 0.4.5, 4.5 milliamps. So that is how you do part 1. So for part 2, you are measuring current. So you don't necessarily need to use the multimeter. And there's an InLab and a 82/M2K version. Make sure you're doing the right one because you can't supply 10 volt plus to 5 volts at the exact same time. So what we're going to do right here is set up this circuit. So I'm going to switch over here. So this is my top circuit. I don't necessarily need that anymore. So I'll rewire it and then show you. Okay, so here's my circuit. I replaced all my components with 10Ks. So if I connect my positive right here, because that's going to be my R1, I believe. Yep, R1. So now the one on the right here, that 10K is going to be my R2. So I'll just connect my white cable. So let me just extract that from this mess. So cool, right there. And then I also need to ground the circuit because if you look at it right here, there's this 10K just floating. Of course, it's connected here and there's a floating section right here. That's just where my ammeter is going to connect, but this part is floating. So I'm just going to ground it right here. So wonderful. And then now I'm going to grab my ammeter. So the positive terminal, since we want to measure the current going through the 10K towards the right, I need to place my positive where that 10K meets. And then, well, if I can get it in, okay, there we go. And then now I'll grab the negative from my multimeter and I'll just connect it to that node where all of the resistors should meet. So there, now we have everything connected properly, just push this in. Okay, cool. So now I'm going to supply 5 volts and negative 5 volts. I was already supplying voltage. You should not do what I did. Make sure you turn off your supplies prior to connecting everything. There you go, 2.5 negative and positive 5 volts. Wonderful. So now I don't have my voltmeter connected, so you won't see anything, but we don't necessarily need to measure voltage. So that is the current flowing through this, through the 10K, which in turns becomes our I1. Of course, you can just rearrange this setup so that way you can measure the current flowing out of V2. So if you put the positive right here, actually I lied, not the positive right there. If you put the positive here and the negative, then you can measure I2. But that's essentially how you do part 3, and sorry, part 2. And then now part 3 is a harder one to do. Okay, so the objective of this portion is to simulate a dependent source. Our dependent source will be manually controlled. So V1 and V2 will be set using our power supply, but we are supplying a third voltage source. The way we do that is by converting one of our signal generators into a constant voltage. So you're essentially making a DC power supply using your signal generator. So that's how we will use this. And then we'll just input values until the voltage supplied equals 1,000 times the current that we are measuring. So here's my circuit right now. Oh, it's not connected right there. Okay, there we go. So here's my voltage. So now what I'm going to do is go over the components. So that's my 1K. Okay, that's the 1K. That's a 2.2. I might just swap that out as a 3. And then that's the 4.7. So 4.7 gets -4. That's going to come from my negative power supply. The 1K is going to get 5 volts. And then over here, my 3K, I'm just going to connect my yellow cable. And my yellow cable just has a green wire attached to the end, and perfect. So I don't need to necessarily ground anything else. But now I need to come in with my ammeter. So you want to place the ammeter in the right orientation, so that way you are measuring the correct current. Okay, so I have wired mine right. So it's going to be harder to do. Let me see. Okay, wonderful. So I'll have my current on the right side, have my voltage on the left. Okay, so now I'll start adjusting this voltage. And as I adjust it, you'll see a change in the current measured. So you see how the current changed drastically. So I had my cables connected the wrong way. So that's why you're measuring a negative. But there we go. So we want the voltage that we supply to equal 1,000 times less than our current. So I'll just keep adjusting it until I can get somewhere that looks pretty close. So let's just try 1.5. This is something you'd have to tweak with experimentally. Okay, so 1.75, I'll just keep doing this. Okay, so I got closer around 1.7. So I'm closer at 8, 1.8. Okay, wonderful. Let me just do some 5 again. Okay, so I would say this is pretty close. And then 7.1. Yeah, that's almost exactly the same. Of course, that hundredths digit is not right, but that's pretty close if you think about it. So the voltage supplied is 1,000 times less than the current measured, and that's what we need. So the measured current has to be 1,000 times greater than the supplied voltage, and so that's the voltage that you are worried about. And so that should be the voltage of your current source. Of course, I did change a component, so this 2.2K is different. So that's why I will get a different current measured. Current measured than what you would get. But that's how you would do lab 3 for ECE 286, 285. Good luck.